While QuantumScape promises 15-minute charging by the late 20s, Chinese companies are already claiming 3-minute full charges with solid-state batteries in 2025. With $830 million in government investment, China could dominate the global EV battery market by 2027. Welcome back to Curiosity AI Podcast. I'm your host, and today we're diving into the most critical technology race of our lifetime. The battle for the future of electric vehicle batteries isn't just about better technology anymore. It's about which nation will control the most important industry of the next decade. We're talking about solid-state batteries that charge in 3 minutes versus 15 minutes, government investments of nearly $1 billion, and claims so audacious they sound like science fiction. Huawei patenting batteries with 3,000-kilometer range that fully charge in 5 minutes. Today we'll explore how China is quietly revolutionizing battery technology, while Western companies make headlines with distant promises. We'll break down the science behind solid-state batteries, examine the geopolitical implications of China's massive investment, and reveal what this means for every consumer considering their next electric vehicle purchase. The stakes couldn't be higher, and the results could reshape the global economy. Let me explain why solid-state batteries represent such a massive breakthrough. Traditional lithium-ion batteries use liquid electrolytes. Think of them like the blood in your veins, carrying electrical charge between battery components. But liquids create problems. They can leak, they're flammable, and they limit how fast you can charge without causing dangerous heat buildup. Solid-state batteries replace that liquid with solid materials. Imagine replacing blood with a solid highway system that carries electrical charge more efficiently and safely. This eliminates the fire risk, enables much faster charging, and dramatically increases energy density. Here's where China's approach gets fascinating. While QuantumScape focuses on ceramic solid electrolytes, think of them like solid glass highways for electricity, Chinese companies are pursuing sulfide electrolytes. These are more like solid crystal highways that conduct electricity even faster but are much harder to manufacture. The breakthrough comes in the details. WeLion New Energy has already deployed semi-solid batteries in NIO vehicles, achieving 360 watt-hours per kilogram energy density. That's like packing 50% more energy into the same space. Meanwhile, Huawei claims their nitrogen-doped sulfide approach could reach 400 to 500 watt-hours per kilogram with 5-minute charging. The manufacturing challenge is extraordinary. These batteries require moisture levels below 1 part per million during production. That's like building computer chips in space-level vacuum conditions. The moment China pulled ahead came with 3 simultaneous developments that Western companies simply couldn't match. First, CATL demonstrated their Shenxing Plus technology, delivering 520 kilometers of range after just 5 minutes of charging. Not in a laboratory, but across 67 different vehicle models in 2025. Second, WeLion New Energy moved beyond prototypes to actual commercial deployment. Their 150 kilowatt-hour semi-solid battery packs already power NIO vehicles, delivering over 1,000 kilometers of range under optimal conditions. This isn't a promise for the late 20s, it's happening right now. Third, and most audacious, Huawei filed patents for nitrogen-doped sulfide batteries, claiming 3,000 kilometers of range with 5-minute charging. If these specifications prove accurate in real-world conditions, they would essentially eliminate charging anxiety entirely. The manufacturing scale tells the complete story. WeLion has 4 battery facilities under construction, including an 8 gigawatt-hour solid-state facility in Beijing and a massive 20 gigawatt-hour plant in Zibo. This represents more solid-state manufacturing capacity under construction than exists anywhere else in the world combined. Meanwhile, QuantumScape projects commercial readiness for the late 20s, meaning consumers might not see these batteries until 2028 or 2029. China is building the factories while America is still perfecting the prototypes. In July 2024, the Chinese government announced an $830 million investment program specifically targeting solid-state battery development, This funding supports 6 major companies: CATL, BYD, WeLion, NIO, FAW, SAIC, and Geely. This level of coordinated government investment is simply impossible in Western market economies. The geopolitical implications are staggering. Control over advanced battery technology would give China tremendous leverage over the global automotive industry. Countries seeking to transition to electric vehicles would become dependent on Chinese technology, creating new forms of economic interdependence. Think about the automotive supply chain transformation. Traditional companies specializing in internal combustion engines would see their markets disappear even faster than current projections suggest. Meanwhile, Chinese battery companies would control the most critical component of every electric vehicle. The geographic concentration is the key strategic element. While solar panel manufacturing moved to China over 2 decades, battery manufacturing is consolidating there right now. CATL alone produces more batteries than all Western companies combined. Adding solid-state supremacy would make this dominance nearly insurmountable. For Western governments, the challenge is developing competitive alternatives quickly or accepting long-term technological dependence on Chinese suppliers. The window for meaningful competition is narrowing rapidly as Chinese companies move from laboratory prototypes to commercial deployment. The economic transformation extends beyond automotive. Grid-scale energy storage, consumer electronics, aerospace applications, solid-state batteries could revolutionize every industry that depends on portable power. Let's talk about how 3-minute charging changes everything about electric vehicle ownership. Imagine pulling into a charging station and adding 500 kilometers of range in the time it takes to buy a coffee. This eliminates the primary remaining advantage of gasoline cars and could accelerate EV adoption beyond all current projections. For consumers, this solves the fundamental planning problem with current electric vehicles. No more calculating charging stops on road trips. No more anxiety about finding available chargers. 3-minute charging makes electric vehicles more convenient than gasoline cars for the first time. The infrastructure requirements are massive but achievable. 5-minute charging requires stations capable of delivering 350+ kilowatts consistently. Current fast-charging networks typically max out around 150 to 250 kilowatts. Building this infrastructure will require coordinated investment comparable to building highway systems. China's approach addresses this through synchronized infrastructure development. The government is simultaneously investing in high-power charging networks while battery companies develop the technology to utilize them. This coordinated approach contrasts sharply with Western markets, where charging infrastructure often lags behind vehicle capabilities. Industrial applications could be even more transformative. Electric aircraft, heavy-duty trucking, construction equipment, industries that seemed impossible to electrify become viable with 3-minute charging and dramatically higher energy density. Emergency services gain access to rapid power restoration during disasters. Military applications become strategically critical when solid-state batteries enable electric vehicles with capabilities approaching traditional fuel-based alternatives. Chinese companies appear positioned to begin pilot commercial production of solid-state batteries by 2027, with meaningful commercial scale achieved by 2028 to 2029. The government investment program specifically targets this timeline through coordinated industry support. QuantumScape and other Western competitors will likely achieve commercial production 1 to 2 years later, creating a window where Chinese companies could establish decisive market advantages. The magnitude of this head start could determine competitive positioning for the entire next decade. Technology evolution suggests battery energy density will continue improving beyond current solid-state targets. Research into lithium-air and other exotic chemistries could eventually deliver 1,000+ watt-hours per kilogram, though these remain further from commercialization. Manufacturing cost reduction will determine market penetration speed. Current solid-state batteries cost approximately $1,100 to $1,400 per kilowatt-hour, significantly higher than lithium-ion alternatives. Chinese manufacturing scale could drive costs down rapidly once production reaches meaningful volumes. International expansion will follow Chinese domestic success. European markets with high energy costs represent attractive early opportunities, while developing nations could leapfrog traditional automotive infrastructure entirely through advanced battery technology. The convergence with artificial intelligence and quantum computing suggests that battery development will increasingly depend on broader technological capabilities rather than focused battery expertise alone. We're witnessing a defining moment in the global technology competition that will determine which countries control the energy infrastructure of the future. China's aggressive investment in solid-state battery development, combined with their existing manufacturing advantages and government coordination, positions them to dominate this critical technology. The competition extends far beyond automotive applications to include grid storage, consumer electronics, and aerospace. For Western companies and governments, the challenge is clear. Develop competitive alternatives quickly or accept long-term technological dependence on Chinese suppliers. The next 5 years will likely determine whether the 21st century becomes known as the Chinese battery century or whether Western countries can mount effective technological responses. For consumers, this means the age of 30-minute charging is about to end. The only question is whether you'll be charging your next electric vehicle with Chinese or Western technology. The battery revolution is accelerating, and China currently holds the wheel. Whether QuantumScape and other Western companies can catch up remains one of the most important technological questions of our time. What do you think? Should Western governments match China's $830 million investment in battery technology? How will 3-minute charging change your transportation decisions? Let us know in the comments, and don't forget to subscribe for more breakthrough technology stories that reveal how the global tech race is reshaping our world. Until next time, keep questioning everything and stay curious.